So let us here solve some problems on first order reactions. The first order reaction is sucrose is converting to glucose plus fructose. It takes place at 308 Kelvin in 0.5 normal HCl. At time 0, the initial rotation of the mixture is 32.4 degree. After 10 minutes, the total rotation is 28.8 degree. If the rotation of sucrose per mole is 85 degree, that of glucose is 74 degree, and fructose is minus 86.04 degree, calculate the half-life of the reaction. So here we write. So let here your R1, R2 and this is R3 are the rotation. We can write here rotation per mole of sucrose, glucose and fructose respectively, because this is given here. Sucrose is converted into glucose plus fructose, so this will be some R1, this will be R2 plus this will be R3. So we can write this equation like this. Sucrose is converting into glucose plus fructose. Okay, so here initial concentration will be, this is the suppose of initial, so initial will be suppose A concentration, this will be 0 0, and after time t, so this is the after time t, so after time t will be, this will be your x concentration, this is x concentration, this will be your A minus x. So now we can write here rate constant, rate is, so if you write here rate R1 into concentration of A, this is equal to, this is given here 32.4 degree, so this is 32.4 degree, so this is the first equation. So from here we will get A is equal to 32.4 and concentration of A is given here 85. So we can see here 85 degree is given here, so this is 85, so this is initially 85. Okay, so after is converted into minus 80.6, everything is given here. So total this is the R1, this is your R2, this is your R3. So total will be how much? Total will be your A minus x into R1 plus x into R2 plus, this is not plus, this is your minus R1 plus x into R3 is equal to 28.8, because the total rotation is 28.8 degree. So on solving we will get here x is equal to R2 minus R3 minus R1, this is equal to 28.8 minus 32.4. so this we will get answer minus 3.6. so again we will get here, so we can solve this one equation here. X is equal to x into 7.4 minus 86.04 minus 85, this is equal to minus 3.6. so we are substituting the other value because it's given over here. So after giving this one, so on solving we will get here x is equal to 0.022. so now we can use the formula for this one, first order reaction 2.303, and here time is given how much? 10 minutes. So time is 10 minutes, log of, so initial concentration is how much? So they have given here, so 0. So initial concentration is here, so here this is the initial concentration, this is 0.38, so this is our initial concentration. So here you write here 0.38 and this will be 0.38 minus 0.022. so this is the x value, this is x value, this is the A value. So on solving we will get k is equal to 5.96 into 10 power minus 3 per minute, or we can write here half life will be 116.2 minutes. That is nothing but the so 0.93 divided by this one, this will get answers. So in the inversion of cane sugar in presence of an acid, the following polarimeter readings are obtained. Time in minutes, this is given here, and rotation in degree is given here. So here what happened, inversion of sugar is converting to sucrose is converted to glucose alpha glucose and beta, some alpha glucose and different type of glucose they are converting. So in that conversion, what will happen? The conversion of this sucrose is decreasing order. If the sucrose is decreasing, then the what happens? The degree is increasing. So this is the increase of the degree. Increasing, this is decreasing, you can see here, and this much has been decreased. So this is the maximum decrease. Means here will be cane sugar will be minimum, here cane sugar will be maximum. So we can write here at time t equal to 0, maximum sugar we have. So at t equal to 0, so we have rotation, take rotation will be R0. This is proportional to the mole of sugar. Plus we can write here maximum rotation. So maximum rotation means 0 to, if this is maximum is there 46.5. You can write rotation due to external factor. So external factor means this is nothing but the R infinity. Now second case, at t equal to t. If you take t equal to t, so here rotation will be at t time will be proportional to left sugar plus rotation due to external factor. And if you take at time equal to infinity, so this is the infinite time. So here R infinity will be equal to proportional equal to external factor, because all the sugar will be converted into cane sugar. There is no cane sugar left, so all will convert into this full glucose. So there will be maximum rotations to external factors only. So this is the value. Now if you see here mole of sugar, so this is their maximum rotation is there, we have to find maximum rotation. So if you take this value, so from 1, so here mole of sugar we can write here, most, so here sugar is maximum, sugar means cane sugar is maximum, so this is nothing but I am taking A, so this is proportional to R0 minus R infinity. So this is the external factors. Now second case, if you take A minus X, so A minus X means this one, this is the A minus after t time, so we can see after t time, so A minus X will be your, this is the left sugar, we can write here left sugar is proportional to, this is the RT, so we can write here RT minus this is the R infinite time. So now we can find out K1 for each case. Easily we can see here, suppose if writing K1, then K1 means first this is your K1, this is your K1, this is your K2, and this is your K3. So what will be the K1? So 2.303, time is how much? 30 minutes, and here log of this is equal to, so here R0 minus R0 is equal A minus X, A is R0 minus R1, so here we can write R0 is 46.75 and this is minus 18.75 and divide by for this we have to take it by value. So here write it A minus 41.0 and this will be your minus 18.75. If you solve it, we get answer 3.06 into 10 to the power minus 3 per minute. Similarly, we can find K2, the 2.303, time will be your 90 log of, this is your 46.75 minus 18.75 and here divide by 30.75 minus 18.75. So on solving you will get here 3.11 into 10 per minus 3 per minute. Means this is just different from this one. If you take K3, this one, so it will be 2.303 and here time is 230 minutes log of age same only 75 minus 18.75 and divide by 30. Now this is 12 given here, so right here 12.75 minus 18.75, this will be 3.18 into 10 to the power minus 3 per minute. So here almost all are same, so this is nothing but this is, you can see first order kinetics, we can see here first order kinetics. So average value is nothing, so average value will be K1 plus K2 plus K3 by 3. So on solving here we will get answer 3.12 into 10 per minus 3 per minute. So this is our answer. So So here we'll see the kinetics of the hydrolysis of methyl acetate in acetate dilute HCl at 25 degrees centigrade, and followed by withdrawing 2 ml of the reaction mixture at intervals of T, adding 50 ml of water and titrating with the Barrietta water. Determine the velocity constant of the hydrolysis. Here we have to find again K. Time is given here and titer value is given here. So this is the titer value of, so if you hydrolyze methyl acetate, so what will happen? You will get the acetic acid. So this is the value of acetic acid which is reacting with the Barrietta water. So here if you get this is the maximum value of acetic acid, this is the minimum value. So we have to take the maximum value of acetic acid, that will become the A concentration. Then we will go decreasing value. So this is the maximum, and again we have to take the decreasing value like this. So this is the decreasing, then decreasing, then decreasing, then decreasing. So K1, K2, K3 like this we have to solve it. So maximum is this one, then K1, K2, K3 we will see like this. So first we have to write here volume of alkali used is proportional to mole of acid at that time. So here mole of acid will be maximum. Okay, so we can write here when at T equal to 0, so we can write V naught is proportional to mole of HCl. So when you take T equal to T time, so here volume of T will be, that is proportional to some mole of acid will be also there, and we will get the mole of acetic acid at the time T. So mole of acetic acid formed at T time. Now if you take the infinite time, this is infinite term. So if you take the infinite time, so here what will happen? V infinity, that is V infinity, the volume of the acetic acid will be equal to mole of acetic. This is accession conditions, and here you will get the maximum, that is the total mole of acetic acid. Total mole of acetic acid. So here you will get the maximum acetic acid formed in this case at infinite time. This is always axial. So we can write here A is proportional to, for this one, A is proportional to V infinity minus V naught. So this is our acetic acid. This is nothing but the acetic acid, total ester. So here we will get the total amount of ester. So this is the nothing but the total ester. Now rest of things are left ester. So for left ester we can write here this is proportional to V infinity minus Vt. So this is the, we can write here left ester at T equal to T time. So now we can find the K1 for each case. So this is our K1, this is our K2, and this is your K3. So if you have to check it out whether this K1, K2 and K3 are equal to each other or not. So if you take at T equal to 75 this time, so we can write the formula 2.303 divided by K1 is equal to 75 and log of, so log of here we can see here V infinity minus V naught. So V infinity is this much volume, so 42.03 minus here 19.24 divided by again 42.03 minus 22.24.2. On solving you will get here 3.27 into 10 to the power minus 3 per minute. Now for second one, so K2 means time is 119. So for second one 2.303, here we will write 119, again same thing, 42.03 minus 19.24 divided by 42.03 minus 26.6. So here you will get 3.28 into 10 to the power minus 3 per minute. And again you take K3. So K3 here you get 2.303 and this will be 259. Here log of 42.03 minus 19.24, again for this one 42.03 minus 32.23, this will be equal to 3.26 into 10 to the power minus 3 minus per minute. So if you compare it, this is just like a first order kinetics. You can see here this is the first order kinetics. So we can take the average values. Average value means K1 plus K2 plus K3 divided by 3. So you will get on solving 3.27 into 10 to the power minus 3 per minute. So this is our answer. The inversion of cane sugar proceeds with half-life of 500 minutes at pH equal to 5 for any concentration of sugar. However, if pH is equal to 6, so here concentration is 6, the half-life changes to 50 minutes. So for pH half-life is 500, for pH 6 half-life is 50 minutes. So here we have given equation. So we have which of the equation of rate law expression is correct. So we have to find out. So we can write here. So for half-life of sugar, that is given here proportional to concentration of sugar, that is 0. So because they have given any concentration. So this is the any concentration, means this is the pseudo-molecular concentration. So we can write for rate of the sugar, rate of the reaction will be your K into sugar to the, here acid is there. So acid is, we don't know the order of this acid. So first half-life they have been 15 minutes. So for first one we can write here, again we know the half-life, that is T half-life is proportional to 1 by concentration into n minus 1. So in this way we can write here, for 500 minutes the half-life is 500 minutes, case 1. So 500 is equal to proportional to concentration of H plus, and this will be your 1 minus n, or we can write here 1 minus x, because we have to find it x here. So this is equal to proportional to concentration of H plus is 10 to the power minus 1, because pH is 5, means x will be how much, H plus will be 10 to the power minus 5. So put this value, this is again 1 minus x. So this is case 1. Now second is half-life is 50 minutes. So either half-life 50 minutes, we can write here proportional of H plus will be how much, 1 minus x, because pH is 6. So here H plus will be how much, 10 to the power minus 6. So we can put this value. So here this will be 10 to the power minus 6, 1 minus x. So this is the equation 1, this is the equation 2. So we can divide it, 1 divide 1 by 2. So this is the 500 and divide by 50, and this will be equal to H plus is 10 to the power minus 5, this divided by 10 to the power minus 6. So whole will be how much, 1 minus 6. So on solving you will get, this is your 10, and this will be your how much, 10 into 1 minus x. So we can say here 1 minus x is equal to 1, or we can say x is equal to 0. So rate will be how much, so we can put this value here is there. So rate is equal to K is equal to sugar, and this is equal to H plus, this is 0. So this is our answer. So from this we can compare. So here B is the correct answer. So we can write B is the correct answer. So this is our answer.